Boom. All right, here we go. Here we go. Here we go. All right, so we're going to start with some givens. We need to know kind of what's going on. So tell whether each segment lies on a perpendicular bisector, on an angle bisector, or neither. And justify your answer. That's it?
Was he mad about that?
Yeah, because I wanted to... Alright. So, I wanted numbers. Numbers. But oh well. Okay, so, we know a couple of things. We know that these are congruent. We know this is right. We know this is congruent. Okay? So, there are some things we need to know about two types of angles. One is when you have a triangle, and we're talking about an incenter. The incenter is made by perpendicular bisectors, right? Okay? And they will meet inside if it's an acute angle, outside if it's an obtuse, and on the hypotenuse if it's a right. But the incenter, right, is this is circumcenter is by this. So circumcenter is when you have a circle, right, going through all the points of the triangle. Okay, and to find it, you always do you do perpendicular bisectors. And so from this point, all these distances will be the same. Okay. And then the other thing is if we want to find the incenter of a triangle, right? The incenter is going to be found by doing bisectors. So angle bisector. Yeah, an angle bisector. This is going to cause what's called the incenter. And the incenter will create a circle where the perpendiculars, right, are all the same distance. So these perpendiculars become your radius or radii of the circle. Okay? So the two different things is with an incenter, you have these which are perpendiculars, but they're not bisectors. They're just perpendiculars, right?
Yeah.
And you have these which are bisectors of an angle, right? So they bisect these angles, right? And then you have, with this, they're perpendicular, but they're bisect the sides. So with the circumcenter, you have perpendicular bisector of the sides. So each side that they're bisecting is congruent. Does that make sense? And what they're asking us is which segment lies on a perpendicular bisector and which segment is on an angle bisector. Okay? And so when we look at this, when we look at AE is here, right? And so that cuts this angle in half because these are equal.
Caitlin to the high school.
So that's called a
Caitlin to the high school office.
Angle bisector. Does that make sense? Because it cut this angle in half. Does that make sense? Right? Okay. Now we'll look at the next one, DG. DG is this. And it cut this segment in half, and it's a perpendicular. So we call that a perpendicular bisector. Okay? And then we'll look at BG. BG is this one, right? And does it cut an angle in half?
Yeah.
Are these equal?
Yeah.
They are. So it cuts that angle in half. So it's called a angle bisector. Is that right?
C.
Okay. All right. And CR. So CR. Now, this one's a little harder. Okay. So let's talk about this one really quick. Okay. So what's going on here is when you cut this in half and you cut this in half, they intersect at what's called the end center, right? That means the line segment that connects this end center to this other point has to cut this in half. So it has to be what we call a angle bisector. Does that make sense? It's the third angle bisector. If these two intersect right here, then that means this angle bisector will also intersect right there. So that line has to be an angle bisector. So this line is an angle bisector. Does that make sense? Because these other two lines all intersect right here. Those two angle bisectors intersect with that same angle bisector. Does that make sense? So that's why it's an angle bisector. So you can explain it by saying it intersects with two other. So it intersects with two other angle bis. Does that make sense?
Yeah.
Because it intersects with two other angle bis, it's an angle bisector.
Would it be the same thing with F and R?
With the which one?
With F and R?
Ah, good. Let's talk about that. So,
Yeah, wouldn't it be just angle bisector too?
Wouldn't it be what's on 23?
it looks like, well, we know it's perpendicular, right?
Yeah.
But it's not a bisector, right? So what? You know what this is called?
What?
So this is there's a circle here, right?
Oh, so it's called circle.
And this,
So it's in-center?
yes, it's what's called the apothem. Okay, I don't think we learned that yet. We'll learn it later. But what this is it's a perpendicular radius to the incenter, but it's not a bisector. It is the same distance as this one is. You see that? If there was a line there, these two would be congruent. Does that make sense? Now, if there was a line to here that was perpendicular, it would also be congruent. Does that make sense? In fact, it would look more like this. Right? So this, and this would be congruent. Okay? Does that make sense?